Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. In episode 96 of the Network Plus Prepcast, we explore one of the most foundational elements of network defense, firewalls. These devices are responsible for controlling traffic at the boundaries of a network, enforcing policies that determine which packets are allowed to pass and which must be blocked. Firewalls serve as the first layer of security, examining each connection attempt to determine its legitimacy. Their primary role is to define and control the entry and exit points of a network. For the certification exam, a deep understanding of firewall behavior, especially the differences between stateless and stateful inspection, is essential. Stateful inspection is central to how modern firewalls operate. Unlike older methods that evaluate packets in isolation, stateful firewalls are able to track ongoing sessions and make decisions based on the context of a connection. This means they can monitor traffic flow in both directions, keeping track of connection state and allow or deny traffic based on whether it fits an expected pattern. This dynamic approach allows for greater precision and reduces the chance of permitting malicious activity disguised as normal traffic. The exam will test your understanding of how state tracking enhances security, compared to simple packet filtering. At its core, a firewall is a traffic filter. It uses a set of rules or policies to examine each packet that attempts to enter or exit the network. These rules evaluate fields within the packet header, such as source and destination IP address, protocol, or port number, to determine whether the packet should be allowed or denied. Firewalls can be configured to apply rules in specific directions, such as inbound from the internet or outbound to external services. They enforce the organization's security policy by allowing only approved communications and denying everything else by default. Understanding the difference between stateless and stateful firewalls is important for interpreting how traffic is filtered. Stateless firewalls examine each packet individually without any regard for previous or future traffic. This approach can miss subtle behaviors that span multiple packets, such as session initiation or ongoing conversations. Stateful firewalls, however, maintain a table of connection states and use this information to evaluate traffic in the context of an established session. This allows them to differentiate between legitimate responses and unsolicited attempts, greatly enhancing security without overcomplicating rule sets. Access control lists are one of the primary methods firewalls use to define their rules. An access control list, or ACL, consists of a series of entries that specify whether particular types of traffic should be permitted or denied. Each rule includes matching criteria such as source and destination IP addresses, port numbers, and protocol types. When a packet arrives, the firewall checks it against the ACL in order, and the first match determines the action. Access control lists must be written carefully to enforce policy while avoiding conflicts or unintended allowances. The concept of default deny and explicit allow is a core security principle in firewall rule creation. In this model, the firewall blocks all traffic by default and only allows specific types of traffic that are explicitly defined. This approach ensures that no unintended traffic is permitted through the firewall. It reduces the attack surface and forces administrators to consider every connection that is allowed. Although it may take more effort to configure, this posture is more secure and is considered best practice in most environments. The exam may test your understanding of this principle in various rule-writing scenarios. Packet filtering is the process by which firewalls inspect specific fields in the packet header and apply rules accordingly. This includes examining source and destination IP addresses, transmission control protocol or user datagram protocol port numbers, and the direction of the traffic. The order of rules is critical. Firewalls evaluate packets against rules sequentially and apply the first match. If a broad rule is placed before a more specific one, it may unintentionally override it. Understanding directional logic, such as how inbound and outbound rules apply, is necessary for correctly interpreting firewall behavior. Zone-based firewalls offer a way to group interfaces into logical zones, and then define policies for traffic flowing between those zones. Instead of managing access based on individual interfaces, administrators define rules between zones such as internal, external, or DMZ. This simplifies traffic management and allows policies to be more abstract and easier to maintain. A zone-based model is commonly used in enterprise networks where segmentation is necessary, and the exam may present questions that involve interpreting or designing zone-based configurations. Application layer inspection is a feature of advanced firewalls that allows them to parse the contents of application-level protocols like HTTP, FTP, or SMTP. This is also known as deep packet inspection. The firewall can examine not just header information, but also the actual commands or content being transmitted. This enables detection of protocol misuse, embedded threats, or non-compliant behavior that may be invisible at lower layers. Firewalls that support this functionality can block attacks that exploit application layer vulnerabilities, making them a valuable component in modern defense architectures. Logging and alerting are essential capabilities in firewalls, providing visibility into what traffic is being permitted, denied, or flagged as suspicious. Firewalls generate logs for each rule that matches, and these logs can include packet details, timestamps, source and destination addresses, and action taken. Alerting features can notify administrators when certain thresholds are crossed or when specific types of traffic are detected. Integration with monitoring tools and security information and event management platforms ensures that firewall activity is visible within the broader context of network security operations. Common firewall deployment models reflect different security goals and architectural needs. At the edge of the network, perimeter firewalls serve as the first line of defense against internet threats. Internal segmentation firewalls isolate parts of the network to contain breaches or manage sensitive data zones. Virtual firewalls are deployed in cloud environments or within virtualized infrastructure to protect dynamic workloads. Each model has different strengths, and understanding their application helps when designing a layered defense or answering exam questions that require identifying appropriate placement strategies. For more cyber content and books, please check out cyber.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Firewalls often work in conjunction with network address translation and port address translation, commonly known as NAT and PAT. These functions allow private IP addresses to communicate with external networks by replacing the source address in outgoing packets with a public address. With NAT, entire internal networks can be represented by a single public IP, which enhances security and simplifies routing. PAT goes a step further by also using port numbers to distinguish between different internal hosts. This enables multiple devices to share a single public IP address while maintaining distinct sessions. To support stateful inspection, firewalls maintain connection tracking tables. These tables record details about each active session, including source and destination IP addresses, port numbers, and connection status. This allows the firewall to match incoming packets to existing sessions and decide whether they are part of a legitimate exchange. When a connection is established, the firewall records it. When return traffic arrives, it references the table to determine if the traffic is expected. This mechanism improves filtering accuracy and supports protocols that use dynamic port assignments or multiple concurrent streams. High availability is a critical consideration in firewall design, particularly in enterprise environments where uptime is essential. To ensure uninterrupted service, firewalls are often deployed in failover pairs. In this configuration, one device handles traffic while the other remains on standby. If the active unit fails, the standby takes over with minimal disruption. For seamless transitions, session synchronization may be used to replicate the connection tracking table between devices. Redundant interfaces and power supplies further enhance reliability. These design features support fault tolerance and are likely to appear in scenario-based questions on the exam. Rule maintenance is a continuous task in managing firewalls effectively. Over time, rule sets can become bloated with outdated or unused entries. This not only clutters the configuration, but may also introduce security risks. Regularly auditing firewall rules ensures that each entry is still relevant and accurately reflects current policy, Removing obsolete rules, reviewing usage logs, and validating access requirements help maintain a lean, effective rule base. The certification exam may test your understanding of this process and your ability to recognize the need for cleanup and optimization in security device management. Firewall placement within the network architecture determines what traffic it controls. The most common placement is at the edge of the network, where the firewall filters all traffic between the internal network and the public internet. Firewalls can also be placed between internal zones, such as between departments, or between a production network and a testing environment. In some cases, firewalls are used directly in front of critical resources like servers or databases to enforce more granular policies. Knowing how placement affects security coverage and control is essential for exam design questions. Configuration errors can reduce the effectiveness of even the most advanced firewalls. A common mistake is misplacing rules within the rule set. Because firewalls apply rules in order, a more permissive rule listed before a more restrictive one can allow unintended traffic. Another frequent issue is creating rules that are overly broad, such as allowing all traffic from a trusted network without restrictions. Additionally, omitting return traffic rules in a stateless firewall may prevent legitimate responses from being delivered. Understanding how misconfigurations affect firewall behavior is key to identifying and correcting issues on the exam. The performance of a firewall is influenced by the type and depth of inspection it performs. Simple packet filtering introduces minimal latency, but deeper inspection, such as application layer parsing or full packet reconstruction, requires more processing power. This can lead to increased latency or reduced throughput if the firewall is not properly sized. To address this, many firewalls include hardware acceleration features like specialized processors or offloading cards. These enhancements help maintain performance even under heavy traffic loads. The exam may ask you to identify performance implications based on firewall type or configuration. Ultimately, firewalls deliver a powerful combination of stateful inspection, rule-based traffic filtering, and integration with broader security frameworks. They enforce policies that define what traffic can enter or leave a network, and they monitor ongoing sessions to ensure packets align with established communication flows. When combined with deep inspection, alerting, and logging, firewalls offer both protection and visibility. Whether deployed physically, virtually, or in the cloud, firewalls remain a cornerstone of network security and a core topic for the Network Plus certification. To recap, firewalls play a crucial role in controlling access to and from networks. They apply policies using rule sets, perform state tracking to follow active sessions, and incorporate functions like NAT and PAT to manage addressing. Their placement, configuration, and maintenance are all critical to their effectiveness. Stateful inspection enhances their ability to identify and manage complex traffic patterns. As a fundamental component of perimeter defense and internal segmentation, firewalls continue to be one of the most important and exam-relevant tools in the network security toolkit. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cyber Security Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.